The topic of my talk is about testability, and testability is about making things simple. So this is really good. So what are we going to talk about? How I have structured this talk is, initially we go over the introduction, briefly go over what this talk is about and who is it for. So if you think in the first slide it's not really for me, you can walk away and I will not mind at all. What are the objectives? So, all of us are spending 1 hour, 1 hour, and actually time is very, very precious. So my intention here is that after this hour you have spent, what are you going to get out of it? So, I'm kind of setting up my commitments here that, hey, this is what you should expect out of this 1 hour you're spending. We'll briefly go over testability, so that all of us are on the same page. We'll talk about, is it easy or hard to implement testability? What are the key considerations that are going on in our mind when we think about testability? And talk a little bit more about that. We'll look at an example, and this is kind of a very simple example that happens over and over, that I have seen happening over and over in different features which I have tested, and kind of exemplifies that, hey, this is the problem that happens, and this is how we approach it. And is there another way, or is there an ideal way to approach this problem? So here, then I talk about some real life examples. So here's where, we all try to learn from our mistakes. So I have, this is wherever all the projects that I have been at Microsoft and elsewhere, problems that we have faced and the approaches we have tested, we have taken to test that particular feature, and how we could have done it differently. So you will see a lot of code. The code is simplified to fit on the screen, and I would say it's real, but it's kind of inspired. So in case any resemblance to real or dead code is purely coincidental, so don't mind, hey, that's my piece of code and that should not be. So it might happen. We'll talk about, and from each of these examples, what is my idea? So we humans are very good with pattern matching. Whenever we see a problem, or we identify a class that, hey, that problem looks very similar to what I am doing, and maybe I can apply that solution here also. So that's my intent of giving a lot of real life examples, and then from these examples kind of deriving a checklist. And what is this checklist all about? So you think about it that when we do any kind of testing, right, we have a checklist for globalization. Have I done Chinese characters? Have I done, Great Britain, SQL? SQL correlation, this, that, security, okay, have you done database fuzzing, this fuzzing? But my intent here is there is no, kind of checklist for testability. What my intent is that all of us at the end will have a checklist that we can apply to our features. We talk about, design for testability. So what is this about? We kind of say, a car is designed for performance. So, although it just gives 5 miles an hour, but, it goes 0 to 60 in 2 seconds. So that's really good. It's designed for performance. In this case, what is this design for testability? So do we actually now design for testability? What's that all about? We go and we kind of, from whatever we have learned, we go back and, fix it, kind of change the test case as to, okay, how it should have been ideally. And we, talk about the customer impact for testability, and we summarize. And there is a bunch of resources at the end. There is no Q&A. It doesn't mean that you can't ask me any questions. What it means is you can interrupt me anytime and, feel free to ask any questions. So what is this session about? There have been a lot of past research and, articles that have been written about testability. What is testability all about? As a show of hands, how many people actively, think about testability when writing code? So that's a very good number. So, it's about 60%, so which is really good. I would like the number to be 100% and always. So this talk is not about explaining what testability is, or neither how to implement testability, that, hey, this is a test hook here, and that's how you can implement it. This is not about that. It's more about why is practicing testability difficult in real life, and what can we do about it? And who needs it, right? So many times it's confused that, oh, it's testability, so there's a word test there. Maybe it's just only for testers. And I argue that is definitely not the case. It makes testing simpler, but there's also a design aspect of it. And there is also, so what's developers, testers, and PMs? So I'm from Microsoft. So developers, our feature teams are usually divided into three kinds of people. First are the developers who are writing code, the testers who are, okay, is the code correct? And the PMs or the program managers are we building the correct thing? So this is, the three kind of people who usually form a feature team. So there is something in it for everybody. For the testers, it's definitely making testing simpler. For the developers, we will see that how come, seeing your test case, it kind of hints at your design. Do you actually have a well-designed, software component? And for the PM is, overall there is a reduction in costs. That's what we are here for. And as a program manager, you always want more and more features to be built in the product. So if you can actually reduce the cost of building those features, you can get more features in. So let's look at the objectives. So this is what you will get out of this 1 hour. All of us will be able to summarize testability. What is testability? Explain in simple terms. We'll all be able to talk about the challenges of testability. How many people feel that we write a parallel product to test the product? So any feature, you have to test the feature, you kind of write another piece of test framework or automation that is as complex as the feature you are testing. How many people get that feeling sometimes? So why is that the case? Does test code have to be that hard? So just thinking a little bit more about that, the real life examples and the checklist, and also about testability plus. So there are some other considerations to make, for the same aspect of making testing simpler that is not covered in the core testability principle. So I think this is kind of an extension to the core testability principles for the same vein of making testing simpler. So what is testability? So I have borrowed a couple of slides from David Catlett. He's a test architect at Microsoft, and he has invented a simple model for testability. We'll look at that. So this is the IEEE definition of testability. It's quite wordy. I'm not going to bore you with these wordy slides in my talk, but I just wanted this to be here. So the two words that for me are really important. It is a degree, and it makes it relatively easy. I'm not going to read this. So there are two things that prop out. First is that there is no measure to it. When we talk about code coverage, we say that, okay, you have 80% code coverage in your code. When we talk about cyclomatic complexity, we say, hey, there's this number. Right now, there is no measure for testability. This is an area of active research, but till now, there is no measure. So it's a degree. It's kind of what you think. It's always, I think with engineers, at least, I get very uncomfortable if I have to feel things. I'm more kind of, okay, let me see the code. What is the number? It gets a little tricky. And the other thing is, it's relatively easy. So let's kind of simplify this definition a little. So there are two things that kind of come up, right? The cancellations are not something that I kind of did it right now. It's by design. So what that means is that how easy it is to test. So I want to really, really drive home one point that we want to make our testing easy, okay? And we want to make our testing simpler. So the idea here is not simple. I'm not saying that, okay, suddenly all testing is going to become simple when we apply testability principles. The idea is it will become simpler from what we are doing right now. And although we can't measure testability, there are ways whereby we can determine how good or bad your feature is on the testability quotient. So let's look at that a little bit further. So we know what is testability. Why do we actually need it? So at the end of the day, it all kind of boils down to money in some shape or form. So here's the thing. In all projects that I have been, testing is usually the long pole. We always seem to be short of test resources or time when it comes to this. Okay, we have not tested this thing perfectly. So testability, ensuring you think about testability makes your test cost go down. It makes your testing simpler, and it makes your test cost go down. So that is really good. There are some other important benefits also. One is that we will see, so think about there's a feature that is easy to test. Something that easily pops up is that you can easily see what is going on in that feature, and you can make that feature, do things. So let's say it's a state machine, you can make it go here, there, very easily. What that means is manageability, so if you're maintaining that feature, that becomes simpler. And another subtle point is, these are kind of, when you think about them, these are kind of features that will help self-diagnosing and self-correcting software. So think of I can see what I'm doing, and I can change what I'm doing based on what I'm seeing. That's where self-correcting and self-diagnosing software comes in. That hey, okay, I'm not doing right. I know what I'm doing, and I'm not doing something right. So I can change myself very easily. So these are kind of the building blocks there. And what are the design impacts? So I'll talk about this last point in detail at a later slide. So testability can be broken down into smaller principles. David Catlett has come up with this SOC model. And this is kind of a good tool just to, since right now it's all about thinking, you have to think about it all the time. So this is a good model for you to break testability down into smaller principles. So instead of this big chunk, you kind of simplify it. You kind of break the problem into smaller pieces and say, okay, SOC. So let me think of testability at these 4 principles. What are these 4 principles? So S is simplicity. So just think of those, look at those diagrams there. If you have think of a feature that has one simple code path versus a very complex kind of a feature which has a lot of dependencies. So obviously the simpler it is, the easier it is to test. It's a no-brainer. Observability, if I know what is going on, that hey, there's a bug right there. What you did is not correct, or it threw an exception. I can very easily test it. Control, this is, let's say it's a state machine, and it can have multiple, it can have various permutations. And now, can I make it take a particular path? I want this particular flow right now. I want to test, my use case is testing this particular flow. Can I do that? If I can, it's easy for me to write that test. And knowledge. Knowledge is, okay, I know this has happened, is this right or wrong? Okay, so these are very 4 simple principles, SOC. Is it easy to implement testability? So testability is nothing new. It has been there for more than a decade. In the software field, it has been there before. In the electrical engineering field, a lot more than that. And the first time when I read it, or anybody reads it, it's like the greatest and the best thing that could have happened. It solves, it makes your testing simpler, it reduces your costs. So all of us should just be doing it. But what I noticed is we don't really pay a lot of consideration for those testability principles. Why I kind of think, why are we doing that? Does testability means making tests simple? So that is not the case. Sorry to say that, but it's not the case. It's not that you're going to suddenly make your life simple. Life is going to be simpler than what it is right now. So think of you are testing the Java JIT compiler or the SQL Server optimization engine. These features are complex. So your tests are going to be complex. But still, they can be simpler from what they are right now. So that's what the point I'm going to make again and again. Simpler from what we are right now. And what are the effects? How many of, there was, I'm not going to make you answer this, but there was a question asked that, how many of us have flaky tests? And almost more than 50% of us said yes. I kind of hate flaky tests. I get very passionate. I'm like, okay, I want to see what the test is, who wrote it, and why did you write it? Because think about it. Whenever a test is written, it runs for like 10 years, and it's running every day for 10 years. Even if you spend like 1 hour when there is a failure, and think about 10% or 5% of the time it fails, think about the total time you're going to spend, and then add on to the new, people are always moving, so there's somebody new is coming in, and there is that inertia for him or her to learn that test code and how it works. So what is the effect of testability on test stabilization and automation depth? It has positive, we will see that it has positive effect on both test stabilization and automation depth. And development cost. So is it all free? Can we say that, okay, we want to do this for testability, and let's do it. So is this free? Well, nothing is for free here. So the way I think about it is that we think of, we always think of cost as a whole, for the feature as a whole. Okay, we are going to take this much time to design it, this much time to code it, and then this much time to test it. It might happen that to implement a testability measure, or some kind of, you want to better a testability aspect of it, it will take you 2 days to write that code. Well, that's fine, but you have to think about how much time is it going to save you to test it. If it is going to save 10 days of your test cost and increase 2 days of your development cost, it's still a net gain. So we have to start thinking about things as a totality, think of all costs. So here, I think there is an interesting aspect, to consider when we are talking about testability. How many of us have taken any, testing courses while in school or college? Anybody has taken? So, I would say around 10%. And how many of us knew what an SDET role is? Or, an SDET is a test developer role. How many of us knew that a role like this exists? I just see 2-3 hands. So honestly, I had no idea what a test developer is. When I got interviewed as a test developer, I was like, what does that mean? I don't understand. And I was told, oh, don't worry about it. You're going to spend 80% time writing code. Oh, I'm in. 80% time writing code, I'm in. I really don't want to know anything more about it because I didn't know. When did I write test cases when I was in school? Okay, so I've written my code. Okay, so I had to design an OS. So, okay, this is my OS. And these are all the tests that my professor has prescribed. And I have to ensure that all those tests pass. Otherwise, I need an A grade. So, I need all those test cases pass, I get my grade. So that is kind of good. So that's what it has been for me always. Testing has always been an afterthought. Okay, I've written all this, now I need to test it. So that, in my opinion, is kind of the problem. That we don't even know what should a tester think like? What's the psyche of a test developer? In my opinion, we always start thinking about, how are we going to test this right up front? When we are thinking about the feature design, even the feature, okay, what is this feature going to be like? When we are in those meetings, thinking, okay, this doesn't make sense for the customer. We need to design in that way, this way. We also have to bring in this aspect, okay, this is how I'm going to test it. Now, how am I going to change the design so that it is easier to test? It has to be right up front when we are actually designing the software. This is what happens always, right? We all write test frameworks. I kind of always, I have this quotation mark because I always get very tense, why are we writing this code again and again and again? Have we not seen these things before? So we write this test framework, and typically what happens is you have a complex feature, you end up writing a complex test framework, and we are very happy with it. You get to write a lot of code, it's kind of complex, we learn a lot of things, we get very happy. We never ever think that, the complexity in the code might be that it is a poor testable design. It's actually bad, and that's why your test code ended up being so complex. Can we actually ask somebody to go and fix it? So that is the thing that I want to drive, that, you don't really, your test code doesn't have to be necessarily complex. You have to think about going back that, I want to keep my life simple here. So what changes are required to do that? And that's the whole idea. Always start thinking about how am I going to test it? How am I going to test it? So this is an example. So we spoke a little bit about concepts, and what I now want to move to is just take an example so that it kind of solidifies these concepts in our mind. So this is a feature that I was testing initially when I started at Microsoft. And what this feature is there was this object factory, and it exposed that, so it's an asynchronous object serialization API. So it was the create and store API is an asynchronous API. What it does is it takes in parameters, it takes in a couple of parameters, it creates an object based on those parameters, and then it serializes that object to a persistent store. Very simple. And how does it get the persistent store information? It gets it from a metadata store. Okay? So it knows I have to contact this metadata store. That has got set up during product installation. So this is a huge piece of software. This is the product, and it gets installed. There is this metadata store. It has information about persistent store, and then that's how it works. Okay? So this is an asynchronous API. So let me show you, what was the first test case I came up with. So this was the first test case, very simple. What it does is it sets up the product. It has some 2 parameter values, A and B. It invokes that API, asynchronous API, and then this is a test. So this is this is the product API, and then this is a test function validate persistent store. What it does is it queries the persistent store, checks whether the object is present or not, and if it is, it runs true or false, and that's what the test case does. What do you think are the problems with this test case? Yes?
There's no synchronization between the create and store, and there's no way for you to know if it's been put into the persistent store.
Okay, so synchronization is a problem. That's a good answer. That's a very good point. Yes? What are the other problems with this test case? Yes? Okay, so it doesn't validate the size of the?
I mean, so in the files may not necessarily be the same.
Okay, the files need not necessarily be the same. Okay. So the object, it's not kind of very clear what it is doing. Okay. You had a point, yes?
If it throws an exception anywhere in there, you don't get any results at all.
Okay, so that's actually a very good point. So if it throws an exception, you don't know what is happening. And also to just add on to that point, okay, I think somebody else had another point. So yes?
You don't know what your valid inputs and outputs necessarily are.
Okay, so you don't know what your valid inputs and outputs are. So the point is, which is a very good point, you don't know what you are testing against. You don't have any range or anything like that. Yes? Pardon? You don't have the test? Okay, so you have not looked at the output to actually find out whether it's actually passed or failed. Okay, so let me just say that for now let's assume that this guy is actually looking at the output somehow, the validate persistent store. It kind of looking at the output. The output is querying the persistent store. Oh, test pass or fail. Okay, yeah, makes sense. Okay, makes sense. Yes. You had a point?
Well, just the validation isn't parameterized, but the setup is, which means you're.
Okay, so
there's no point in having the flexibility in the create and store if your validation is.
Okay, so that's a valid point. So the validate persistent store doesn't take in any parameters or anything like that. Any other issue? Yes?
If it fails, you don't know why it failed. There could be multiple things happening.
That's a very, very good point. So let me just elaborate on that a little bit more. So the point was that if it fails, you don't know why it failed. And if you think about it, there are 2 operations here. So there's a create and a store. So there are 2 operations that you're doing. If it fails, you don't really know why it failed. Did the create fail or the persistent fail? Okay? Any other issues with this test case? Yes? That's actually a very good point. So it is not really data-driven. It's a very hard-coded kind of test case.
The test case doesn't clean up off itself.
It does not clean up. Excellent point. Okay, so a lot of good points, right? So we looked at the test case, and there are a lot of issues. So I'm just going to pick one, the asynchronization issue. So I'm just going to try and solve one for now. And so I started at Microsoft about 3.5, 4 years ago. And honestly, I was not very intelligent at that time. I still don't consider myself intelligent right now, but I was not at all intelligent. And for me, that's just a nice way of saying that I was pretty dumb or foolish. So this is what I did. Okay. So I realized that how many of us has done this? How many of us have done this? Okay. Thank you. All of us. So I think 50-60% of us are very honest here. So this is what I did. I said, hey, this is a SQL server. This is a SQL server. I work for Microsoft. So this is a SQL server box, Windows 2003, awesome server, with superb TPC ratings. How much time will it take? Half a second, 1 second, 2 seconds? I'll give you 5 seconds. Okay, I'll give you 5. Go. I'm being very generous. I give you 5 seconds. Okay. Okay, it's work. I know. I ran it 10 times. Awesome. Ran fine. And I checked it in. It's running fine. 2 months down the lane, what happened is somebody decided that we have to be more optimized in our, managing our machines. So no longer can we just run 1 test case at a time. I want to run like 20 test cases at a time. So suddenly this poor thread, is getting less time to execute, and things are slower, and this test case failed. So, this has been like, 6 months later, this test case fails. I've become a little bit smart, okay, a little smart. What I do is I kind of introduce a smart sleep, I actually wrote this in my, okay, so I actually wrote this in my review, okay? So, okay, I have a smart sleep. What is, seriously guys, this is SQL Server we are talking about. It cannot, I'm giving you 1 minute now, okay? I'm giving you a minute. And I've become smart now. It's been a while, and there are a lot of smart people around me, so some waves have flown in. So what I've done is, after every 5 seconds, I'll check, and if it passes. Otherwise, seriously, there's something other than this. Okay? There's something other that's wrong. What now happens is, okay, we optimize further. We try to be more efficient with our machines. We bring in virtual machines, low CPU, low memory resources, and I run this. You know what? It fails. It fails again, and I don't know what to do, okay? So I will come back, we'll come back. I don't want to increase the time anymore. It's been 4 years, I just don't want to do that. So we'll come back to this, okay? So this is just to highlight what we are doing, For me, why this test case example is very important, that this is what we try to do. We try to fix the test, we try to fix that code, but maybe the problem is not there in the test case. Maybe the problem is somewhere else. And that's what I want all of us to, fix, or encourage fixing. So we'll come back and solve this example. What I now want to do is, starting from this basic example, I want to give a lot of real life examples. I want to start actually giving real life examples that I've experienced, and build, give you some patterns to think about, and then bring a checklist. How I think about it is, all of us have heard about code smells, that, you see code and, you can see, hey, this doesn't smell right. You probably have a strong coupling there, right? The way I think is that there are similar test smells. You look at a test case and you see, what? Okay, there's some problem with the feature here. The test case doesn't look right. And I want us to start thinking about that. And, and then raise those appropriate things, okay? So I'm going to start giving some more real life examples, and deriving from each of these examples, coming up with checklists. So before I start giving these real life examples, let me set some context. So this is something that happened to me. I'm driving with my wife Smita in a car, and we are very happy. We are driving together, and I came across a sign, and like, what? Like, what is this? And what is that sign? This is that sign. Like, seriously. So I'm with her, I'm sitting with her. What I really want is this, a serene kind of a, fake image, and that's what it is. It's a dead end. But what I see is this, right? What I want to say is, many a times while design, so this obviously became very, very real. We'll kind of, tune back a little and kind of still live in our code world. But what I wanted to really emphasize is, this is what ends up, we end up with when we test something, where that is what we actually wanted it. So when they design, this is what you actually have implemented. This is what your code is. This is what your design is. And now you have to test this. But actually you wanted to test that because that's what you wanted to reach. So that's that's the point. So the first thing that I talk about is the first principle. So what I try to do is I still use the SOC model. So think of the first principle, that is simplicity. So this is, once again, any code resemblance, I'm not responsible for that. So this is a UI. So we had to write a UI, and what that UI had to do is very simple. Go to the database, get some records, and display it to the screen. Very, very simple UI. The developer said, yeah, I can do that. It's very simple. I will, open a connection. Obviously, it's not very perfect, okay? So it doesn't handle exceptions and all that. So code has been made to fit the screen. So some things have been removed. So it opens a connection, executes a data reader, gets some data, and displays it to the screen. Any issues you see with this code? So this is the code. So it takes data from the database and displays it to the UI. So this is kind of the UI grid. So it kind of populates it, and you can see it on the screen. Any issues you see with this code? So yes.
If the database is down, it's just going to crash.
Okay, so good point. What I want to kind of give just a kind of a caveat to all that. So I have simplified a lot of code. So those error checks and all that are not there. Yes. Pardon? Somebody could add a column. Okay, so makes sense. Okay.
There's
no model view separation? Everything is raw SQL straight to the view?
Okay, so that's actually the answer. There was another point.
It's going to run forever if the databases are fairly large.
Okay, so that's a great point too. The answer, I think anybody had a point. I'm sorry.
There's no test fail.
There is no. So this is actually not a test case. This is the product code that we are looking at. Okay.
Database is down.
Pardon? The database is down? Yeah, so yes, I have kind of cleaned up some of the code just so that I can display it cleanly.
If you took in your SQL connection as a parameter,
Right.
it would be mountable.
Okay, that's a great point, and we'll actually see that point there.
Similar to adding or removing columns, you're assuming that your columns are ordered this
Yes,
way.
yeah, that's definitely a bug right there. What if messages don't exist? It's null.
How do you test it? If you have to test it, you have to write the same code.
You have to. That's another excellent point.
Disclosing any resources.
You're not disposing any resources. Okay, so a lot of issues with this code. A couple of things that I really want to highlight is, the one thing I want to highlight, the two things that I want to highlight in this example from the testability aspect is, one is that it makes the database connection right there in the code. So it does not follow the model view controller pattern. So it's actually a thick UI, so the business logic is actually implemented in the UI. And the second problem, which is a very great, which is very good that you actually caught it, is that which kind of hints at the other issue, that the SQL connection is hard-coded, so I can't mock it very easily. Just to kind of illustrate that in a better way is, it's hard-coding the SQL database right here. So if I have to mock it or do something like that, there's no easy way for me to do it. So think about it when I'm actually going to test this, right? So let me tell you two things that happened. Excuse me. So first thing what happened is, so we shipped this V1 version of the product. So it went with this piece of code, and not exactly this piece of code with all those error checks and everything in place. And what happened is, come V2, the customer said, what, I want a script. I want a script to get all the messages. You have it displayed in the UI, but I also want to write an API against it. What we did is that, okay, now ideally, we should have taken this business logic out of this client, put it in a separate code, wrapped it around an API, and then made this client use that API, right? But what are we always short on when we are doing any software projects? Pardon? Resources and time, right? So we are always short on resources and time. So it is, we don't have the time to do all that refactoring. Let me just copy that piece of code and put it in an API. Okay, now we have to, what we are ready to ship, let's ship it, okay? What that has done, it has now, you have redundant code in duplicate places. You have different set of tests, okay? That is really bad, that you have two sets of tests, and now any fix, it has to now go to different places, right? And the second point, which somebody has already has a very keen observation, is that the database is hard-coded, so you can't easily mock it. Think about it that instead of actually having the database name hard-coded in code, it could have been in an API file, in a config file, or whatever, right? So right now here, it is there hard-coded, and how does it get it? It gets it through the metadata and all that, right? So this is really bad. So these are like some examples to consider what is simplicity all about. So simplicity is all about that how simple it is to execute test cases against this piece of code. Can I easily do that? Does it follow basic design patterns, right? So not basic design patterns, but basic design principles. They're good design, you need strong cohesion, you need weak coupling. Does it actually follow all those things? And from this, what do I kind of try to infer is a checklist, right? So this is kind of going to be the recurrent theme for all those 4 principles, that are you actually taking a lot of time setting up and cleaning up your test cases? So we all want to be efficient, we want to run 500,000 test cases in 15 minutes. But if your tests are spending a lot of time setting and cleaning up components, there is a problem right there. There's a strong coupling issue in your framework. You are not going to be able to write a feature test case. You have to write those large test cases because guess what? They're strongly coupled. Are you failing intermittently because some other component has failed? Okay, my test failed. Did there actually feature fail? No, something else failed, and I kind of failed up in the stack. So all these, I don't want to read through all of this, but I want to kind of stress is that whenever you now see your component or your feature and your test case, just try to go over all these questions against that. And this is what you're going to, is going to come up. Hey, there is a problem right there. Let's look at, the next principle, that is observability. What is observability all about? Hey, if I can easily see what's happening, then I will be able to accurately determine whether my test passed or failed. Very simple. The component here is a network load balancer. What it does is, it takes in a message from any client, and it will just route it to one of those, servers that are connected to it. And how does it do that? The logic, the algorithm that it uses is, there is both a static and dynamic time component to it. The static time component is, okay, what's this, how powerful is that machine? Does it have a lot of memory, resources and stuff like that? And also some runtime component that, maybe server A is the most powerful server you have, but it is heavily loaded. In that case, you'll have to, right now at this point of time, you have to route it to B. So it makes a decision based on both static and runtime parameters, that it has. Now let's say you have to test something like that. How are you ever going to test it if all those member variables are internal, they are private? How will we be able to ever determine whether it made the correct choice or not? So for us, it is important that we kind of can see, okay, at this point of time, these were the parameters, and that's the decision I took. Okay, you know what? Your decision was correct. Just think about it that it routed to one of these servers. Do you know which server it routed to? Yes, you can do that. You can write a for loop, and we are all intelligent people. We can write a for loop. We can, okay, it went to this server, so it did not go to this server. And think of the other aspect that, it kind of spits that I am sending this message to server B. Think about how easy your validation of your test case is going to be. You're going to go to server B. Do you have the message? Yes, you have the message. You are then going to be a good tester. You're going to go to A and C and going to say, you guys don't have it? No, I don't have that. You know what? Your test is good. So the idea here is, yes, we can go around and around. We can still write code and effectively, correctly test it, but we want to make our testing simpler. Okay. So another piece of software, it's a router. And what this does is, when you have to set this router up, what you do is you kind of give it a name and a URI. So every message that comes in has a destination name to it. And based on that destination name, this router will route it to some particular server. It has these three methods. So once again, I've cleaned up some, so you won't see error handling and stuff like that, so that I can fit it on the screen. So it has three basic methods: add, remove, and send messages. So add will add an entry to this router, add a server entry. Remove will take that server off, and route messages, what it does is it takes in a bunch of messages, and based on their destination name, it will give it to that appropriate server. Now I have to test this remove routing entry. Can anybody tell me how will I test that? I have to test the remove routing entry function. How am I going to test it? Yes?
You kind of can't, because you don't really know for sure what's in the routing table at any time.
You can't. Actually, and anybody else thinks we can test this in any shape or form, using any tricks?
If you kind of add something that you know, then you can verify that this without being certain.
And how can you do that?
If you invoke add routing entry,
Right.
and then you invoke the other one, you check that it's without being certain, correct?
Okay, so I didn't get that. So is there something that is added here, and then you invoke this guy with the same thing? But how do you know that it actually removed it? Yes?
You could use reflection to access routing tables.
You can do that. That's actually a great idea. So that you can do that. Yes?
You can route a message to it, catch the exception.
Okay, so I was actually waiting for this particular answer, not to pick on you or anything like that. But this is what most of us would do, and I actually did that. So what I did is that, okay, I'll remove it, and I send a message, and it didn't went anywhere, or it had an exception, and you know what? I could then verify by means of throwing that exception that this entry was removed. However, there was a bug in this code. And what it did is that no matter what, it always had a default. So I kind of simplified this code. It always had a default router, a server that it would route to, and it gladly sent that message to it. So I could never ever found out. It never threw an exception. So the point I'm trying to emphasize here is that there are some things, if you want to accurately determine whether your test passed or failed, you have to have internal knowledge. So maybe it's through reflection, or maybe it's through traces, right? That every time I remove something, I emit a trace that, hey, I have removed this entry. Or when I add something, I add a trace. So just simple things like these will make our testing much simpler. Yes? Yeah. Routing table. So right now there isn't one routing table. So the question is there a way to read the routing table, right? So right now there isn't one. So I think, is that what you're hinting at, that we could have a separate test interface that could read the routing table? That's also an option. That's also an option. Yes.
But we cannot know.
Yes.
Is there any routing table
That is true. That's true.
to remove?
That's true. That's true. You could have a test interface to do that. Yes.
One way that I've killed two birds with one stone
Yes.
in similar situations
Yeah.
is mocking out the message recipients
Right.
and then feeding the router a fake message recipient,
Right.
which I can then monitor the receipt of a message at. And that allows me to test only to the public interface,
Yes.
but still to validate the entire external process
Right.
of the router.
That is true. But you do realize the point that, so how are you going to validate that the remove actually did the correct thing here?
Oh, I don't care what it does internally. All I care is if I remove it, does it no longer send a message to this mocked out recipient?
I see.
So if I provide it with an inspectable, observable
Right.
target,
Right.
I can validate all of its external behaviors without ever caring whether it has a routing table or a routing list or black magic inside.
Definitely.
Yeah, but you will still like memory leaks.
Yes, exactly, exactly. You will never, we want to exactly pinpoint, right? What's the value of a test case? It exactly tells me what failed. And if in a scenario like that, you will, you think your test case might have failed for that, but it might have failed for a different reason. It may not have routed because of a memory leak, for example. Yes,
Would you consider,
I'm sorry.
I still don't get how to test removing routing table.
Okay. So there are two ways you can, right now with what we have, you can't test it. Okay, you cannot test it. The two ways, the two things that I can easily come up how you can test it is, you can have some traces that, it emits traces, writes it to a log file that, hey, this is what has been removed, so on and so forth. Or you could have a test interface whereby you can query the routing table entries and actually know. So, that's more like white box testing. You actually know what it is doing. Yes.
would you recommend maybe even changing the public interface of this? Like one thing that I would recommend
Yes.
is adding a function to say, is this routable? So not necessarily exposing the routing table, but
I think that's but that's another great example how you could do that.
sometimes you'll get pushback from development teams on that because they don't want to change the API purely for the purposes of testing.
Yes, and I think we need to approach all those problems are that, hey, what is, because the moment you have another API, let's say, there is some test costs associated with it. But you have to think about how much savings will you do to test the remove routing table. So it has to be viewed holistically. Think about it, right? I think I'm kind of, jumping a couple of slides, but this is very important is whatever we do, the customers also do. If we are facing a problem, trying to figure out whether this thing is behaving correctly or not, the customer is also going to run into the same issue later. Any other questions? Okay. So for the observability, another checklist that you have. Some simple points, but more importantly is, can you easily detect if your code has changed any state? Can you verify easily what is the result of your test case, whether it's passed or failed? And deterministically say that it failed because of that, and not because of something that you really don't know about. Stuff like that. We go to the next principle, that is control. And I take an example of a message buffer. So what this scenario is that there are a couple of producers and consumers. Producers are applications that are creating these events, message events, and consumer is one app that is there somewhere in the network that is consuming all these events. What we do is, for the sake of efficiency, we kind of batch all these things into one buffer and then send them over the network. The problem with this is, what we actually did is, we said that, I think given these particular statistics of how these messages are getting generated, the batch size is going to be 10 million messages. So we are actually going to wait till we get 10 million messages, and then we are going to send them across. And now I had to test this. So it comes to me and like, okay, I have to test this. So we need to now generate 10 million messages. Think about how much time does it take now to generate those messages before even testing that, right? It could have been made very simpler if once again, this could have been controllable through a config file that, hey, let's test it with 10 messages. The moment you have 10 messages, why don't you send it across? Another example is, so let's say it tries to send it across and it fails. So what it does is it has a retry mechanism. And the retry mechanism is it will wait for, it will retry 3 times and it will wait for 5 minutes each. So what that means is now it has to wait for 15 minutes before it actually drops the message. Now I have to test the dropping message functionality. So my test case actually waits for 15 minutes before it even tests it. So the basic idea here is very simple, that the moment you are having a wait or a sleep or a polling somewhere in your test case, you have an issue with control. You can't, you don't know what state changes are happening, and you cannot accurately determine. This aspect is very important, because if you can control what your feature is doing, your tests will be more repetitive, can be run deterministically and repeatably. So all your flaky issues, whenever you have an issue with a flaky test case, that sometimes it fails and sometimes it doesn't, you have an issue with control or observability, more with control. So many times what you are doing, what you can't do is, you can't make the product to take a particular path. So that's when I would say, for all of you who have flaky tests, go back and see what kind of changes you can still do. And knowledge. This is the most simplest and the most easiest. So how many times have you executed a test case, seen the results, and then walked to your developer's office that, hey, I saw this, is this correct or not? So your test kind of became an experiment. That, okay, I ran this and I saw this result, is this correct or not? So let's not confuse testing with exploratory testing. So that is one aspect of testing whereby you're deliberately trying different things, but your testing should be kind of deterministic, that, okay, when I do this, I should get this output and I know when it passed or failed. So this is very simple. Somebody made a point that we don't know what range of values we are testing that API against. So it is those things. Do you know what magic numbers your component has? Do you know what range of values you want to test it with? Are there any thresholds? Do you know what are the error conditions? How is it going to behave in an error? So on and so forth. So that was kind of the the basic ideas. We presented a bunch of problems, and based on that, the checklist. So whenever now, what would be really great is for all of us to look back at, okay, with all these problems we have with our test cases, how can we go and make them not fail ever, other than a valid product bug. How I think about it is, we expect when the product code or the feature code is written, we expect that code to work fine time after time and not fail. Like, I submit a message, it might go through or it may not go through. I send an email, you may get it or you may not get it. So that's always a very risky proposition. But with our tests, we are kind of okay with it. It fails sometimes. But what I would want all of us to realize is, we should not be okay with it. If it fails, I am not comfortable with that, and we will go and do what it takes to fix it. So some aspects. So here I just want to briefly talk about some of the advanced some things that I don't think are considered in the basic testability principles, but still make sense in the essence of making our test simpler, and so on and so forth. So I think of a build engineer. So this is a build engineer. So this idea is similar to the visualization concept that James spoke about in the morning. So think of a build engineer, who has to test whether the build is okay or not. His or her life is very simple. I see a crack. You know what? That is broken. Can you go and fix it? Let's say I have to now write test cases against against this bridge. I will, very easy for me to do that. I see this crack. You know what? I'm going to test it. Similarly, what are those cracks? Can we see those cracks very easily in our software? We want to make our testing cheap and simple. How can we do that? We know there are infinite possibilities, but what are the things we want to concentrate on? These are some of the things we need to concentrate on. What are the critical sections of the software, both from a code and a customer perspective, that hey, these are the scenarios my customers really care. So when we are thinking about writing component tests or feature tests or end-to-end or scenario-based tests, what is your scale? What are the knob you are tuning? You have to think about the customer, right? What are the scenarios that the customer will do again and again and again? You know what? I will send an email again and again and again. So you better have an end-to-end test for that. So what are the, so let's say you look at the features and you see that these are your features with less code coverage. You know what? You need test cases for them. There are some features that are churning a lot. You probably want to automate test cases first in that feature. And the last point, which is kind of interesting, is many times we design software saying that, hey, we'll need this 3 versions down the lane, and we kind of add in that complexity in the first version itself. So it kind of goes against the TDD, the test-driven design development. And what it also adds is it adds up these testability, this test surface areas. Now you need to test more things in a hope that it is going to be useful sometime later. So we need to be conscious about all those things. And now coming to design for testability. So what we have seen is software that follows good design principles is very high on the testability rank. So something that is that has strong cohesion, weak coupling, the open course principle. This is really good. Okay, so it usually tends to be high on the testability quotient. So do we now start designing for testability? We say that we have been designing for performance or designing for that. Let's start designing for testability. Is that something we should do? So what's a good, software design is, we all realize, is more, it's more art than science, right? So there's so many things that you have to consider. You think about extensibility versus maintainability and simplicity. You think about, okay, do I make it performant, or do you think of databases, right? So we think about a lot of things and then design our software. I believe that we should now start, if we are not, we should definitely start thinking about testing also when we start designing our software. That how are we going to test it? We think about all these things, all these considerations while design. It may happen that you say, okay, exposing this particular interface or making that particular class public exposes a security hole. I can't write that trace. Let's say if I'm a web application and I store all usernames and passwords, and if I give you an interface to query that, that's really not good. So there might be, for some security reasons, there might be performance reasons that, hey, I will not create I will not create an abstract factory here because I want my code to be really performant and tightly coupled. Makes sense. So you might change for those things. But I take the example of database design. Whenever we design a database, we all design databases which are normalized. Based on some user access patterns, you might denormalize the database, right? That you want to make some queries really performant, so you will denormalize the database. But you don't start with a denormalized database. In the same aspect, you think about all these things. You may take some things which may make the testing difficult, but that is okay. You are making a conscious choice. I have to satisfy some criteria. But other than that, we should always consider testability while designing our software. And so we spoke about, we spoke a lot about testability. Now let's try to come and fix our example. So we looked at our test case, the smart sleep one. So what we realized is there's definitely some control issue here. There is a strong cohesion there. So I actually removed the create and store was left out of this code. So there's a weak cohesion, So there's a weak cohesion there. There is also a strong coupling between the installation of the product and the persistent store. So so the software kind of needs the metadata store to get information about the persistent store. And there is also another problem with this test case, that it has this max timeout inside this test case. What that means is, let's say now you want to run this test case in a very inefficient machine, with low resources, and we know that it is going to take 5 minutes to run that test case. You will never be able to do that because it actually will time out after a minute. So there are a lot of things here. So how do we change it? We go back to the first kind of approach. We don't have any sleep, but it's a little different. What we do is we introduce, so there was another interesting thing, that although it was an asynchronous method, looking at the method definition, the name, there was no way for me to tell that it is asynchronous. So there are some guidelines, design guidelines, that if it is an asynchronous, have a begin or something like that. So what we do is, so this is once again not the correct test case, kind of some representative code. But the create and persist have been broken into 2 separate methods. And once again, it is parameter driven. So it's taking in A and B. You will see that the on complete still doesn't, but it's not that case. So it takes in the create is broken. So if the create fails, now you know that the create has failed. You can just give it a persistent store DB, so you don't have to set up the whole product to do that. You call the product API with a callback. So that callback is actually your test callback. Whenever the method completes, you will get that, you will know. And then you can execute your validation piece of code. So suddenly you have, this piece of code, whenever it fails, it is a product bug. So there is nothing in the test case that can now fail. So that was my intention of this particular example. And what's the customer impact of all this? So here's the thing. How many of you have customers who actually test the product before deploying it on their enterprise systems? So almost 50% of us. So what I believe is, so right now, we don't actually give our test cases to them. We don't give our test code. They actually write test cases. Some of them have scripts, some of them do manual work, so on and so forth. If something is difficult for us to test, it's going to be also difficult for the customer to actually verify whether this is working fine or not. If it is easy for test here in-house, we are going to be able to find more bugs, which is obviously very good for the customer. And another point is going from this repro. So a scenario failed at the customer side, and I say, please give me a repro. And we go back and forth with the customer that, okay, okay, this thing doesn't work. And then he finally says, okay, I did this, and okay, now I get it. The important aspect here is for testability is that, when you think about observability and what's going on, when you think about having debug traces in your product code, so that whenever something fails, you kind of know what happened before it, so it fails. So you go from, give me a repro to no repro needed. You always have a repro. So think about maintaining that software, how easy it is. Right? The moment you get a bug, you also get, okay, this is why it failed. It's much easier for us to give the customer a fix. And at the end of the day, it increases the customer satisfaction. And believe me, we always need more customer satisfaction right now. So that kind of ends my talk. This is just the summary slide. Always think about, so well-designed software, higher on the testability quotient usually is the case. Always think about how am I going to test it, how am I going to test it. Use the testability checklist or any other measure that you have right from the start of your design, at the design and feature, right at the design. Make sure that you have things in place so that you can test it easily. And it's all there in your mind. So right now there is no measure or anything like that. So it's we who have to be consciously aware and push these requirements to our developers or our program managers and make them understand why is this important to all of us. So that's I think that's the end of my talk. If you have any questions, please. Yes. So I would ask him why. And if he says, I don't have time for it, if that is an argument, I will say, I will write that piece of code and I will check it in. Will you code review it for me? Any other questions? Yes.
Something to consider as a developer.
Right.
Is I can't always put code for my testers inside the product.
Right.
Because a lot of times there's an impact on documentation and
Right.
external use.
Right.
For example, if we have an API that's externally published,
Right.
I can't just add a method that I want to for a tester
Right.
because it affects external documentation.
Right.
It has to do with knowledge management and the whole 9 yards. So sometimes it's not maybe the developer isn't necessarily he's not hating on the tester. But
Right.
It's just maybe something like simple reflection or introspection.
Right.
We'll take care of it and avoid API changes or product changes.
Yeah, and I think the point there is, so to repeat the question is that let's say there is a extra public interface that you expose now to make your software more testable. So how do you deal with that? Because maybe there is the documentation issues, so on and so forth. I think there are two aspects, 2 points of this. There may be a possibility that you say that what, I have an external API and it's not supported. So that might be if that is an option. Or the second option is that do I really require that to test it? If I can't test without that, let's say you have an internal member variable and I really need the value of that hash table or something like that, otherwise I will not be able to accurately test the product. So what do we do? Maybe we change the design a little so that maybe I can mock it or I can maybe reflect it, something like that. But we have some things built in to make that simpler. Yes. Yes, sorry. Yeah.
So you've talked a lot about whether to design for testability,
Right.
plan for testability
Right.
in design.
Right.
One of the sort of promises
Right.
of test-driven design
Right.
is that by writing the tests before you write the code,
Right.
it's self-designing for testability.
Yeah.
How do you feel about that?
So this is what I feel about it. I think that we should make the developers write unit tests, because I would want them to feel the pain of okay, what's the complexity of writing tests? Because many times what I have seen is that okay, when a developer is writing unit tests, he kind of will automatically change and make things that okay, I really want to make my testing simpler. So I am a big proponent of that particular for TDD, that we should do that as much as possible.
Do you think that solves does that resolve this question, or is it insufficient to actually make it fully testable?
I think it is. I don't think so. It's sufficient to make it fully testable, because when you might only cover. So it's how many tests or how many scenarios are you going to cover while writing your unit test? It might be the case you cover, let's say 30%, right? But there's another 70% that now you need to test and account for. So it does help, but I don't think so. It sufficiently covers that problem. Yes.
You mentioned a lot about having working with developers
Right.
on integration.
Right.
Do you have any experiences with working with the program managers or whatever that is in whatever particular company?
Right.
In designs of the software?
Yes.
So from the ground up, rather than just speaking straight to developers, from a design aspect, what those conversations would be like?
Okay, so this is how, so I work for Microsoft, this is how it works. Typically we have a feature team whereby the program manager, the developer and the tester all get together even initially in the design aspect. So we undergo design reviews, so on and so forth, right at the start. So we are all very involved at the process. What I typically tend to do is that I can't test that easily, so I need you to change your design somehow so that.
You're talking to the developer now or the program manager?
So the developer, because the program manager is somebody in our companies who is more like, okay, I want this feature. How do you design it? He or she is.
Right, but they're writing the specification. They're describing to the developer. The developer doesn't go to his office and just start typing random code.
That is true. So let's say the program manager says, in case of that router table, the routing table example, that I need to design a component such that I can add, remove, and send messages to it. Right? So that's
So you do that. You go to the program manager and ask for design?
No, so program manager is more like requirement specification, that I need this. And based on that need.
So you don't work with program managers on this at all?
No, sometimes we have to, because sometimes when it's kind of difficult to convince the developer, we kind of take that route that, hey, if I can do this, I can actually reduce my test costs. So that feature that I said that I will not be able to take in because it's high test costs, I'll be able to take in that feature. So suddenly my argument becomes a lot simpler then. Yes.
I just want to point out, we have the situation he's describing.
Okay.
We have someone called a system designer.
Okay.
Who kind of sits between what would be a program manager or
Analyst, okay, okay.
Who then kind of does the overall design,
Right.
partitioning,
I see.
where, how things are going to be laid out.
Right.
And the developers work within that.
Okay.
And then they could, argue testability features. Because they'd say, well, we need a little tool here to look at the state of things.
Thanks. Yeah. That's a great point. Okay. Yes. Go ahead. Okay. Couple of questions.
It's just not the question, it's just a response to one of the questions
Sure.
that are being asked.
Sure.
That how are you going to respond to a developer who says that
Right.
I'm not going to, check for the testability.
Right.
Then as a tester, my response would be just file a bug.
Yeah.
Because it's not satisfying the criteria of testability of a requirement. And so I'll straight on go file a
Yes.
bug that, hey, this code is not testable
Testable.
and it's failing my requirement, it's failing my criteria of testability.
Ability.
And let him do the job, and
Yeah.
then the program manager is there to say.
Yeah.
And I'll file it with the highest priority. It's up to the program manager to decide the business priority then.
That's another last question. Can I take the last question? Yes. Do you have the last? Yeah.
Right, well, I just wanted to add, it sounds like it all comes down to cost, really,
Yes.
right?
Yes.
You can't test. And
Yeah.
Yeah. So, but on top of that, oh darn.
Okay.
Once you put the cost figure in front of the program manager,
Right.
whether or not you want that feature to go through, it's still pass. I think I've dropped my thought.
Sure. Okay. Okay. Thanks a lot. We are out of time. Thank you.